Hey there! You ever look at a math problem and just think to yourself, ugh, that just looks messy? Well, today we're going to tackle that feeling head on. We're diving into something called rationalization, which is basically the ultimate cleanup trick for some of math's most untidy fractions.
So let's just get right to it. We're all told in math class that a fraction like 1 over the square root of 2 is somehow untidy or not simplified. But why? What's actually wrong with having a square root chilling on the bottom of a fraction? Turns out, there's a good reason.
So yeah, let's talk about this untidy denominator. We're going to unpack the why behind this whole rule and see what makes these fractions so messy to begin with. And the official name for this cleanup job is right here, rationalization. All it means is we're removing a surd, that's just a fancy word for a root that can't be simplified, like root 2 or root 5, from the denominator, the bottom part of a fraction. That's our whole mission, get a nice, clean, root-free denominator. All right, let's get our hands dirty with the simplest fix. We'll call this level 1. So how do we fix it? We're going to start with the most common problem you'll see, a single lonely surd in the denominator. The secret is having the right tool for the job, and in this case, it's called the rationalizing factor. This is just a special number that when you multiply it by our messy surd, it magically turns it into a clean whole number. So for the square root of 2, guess what that factor is? Yep, it's the square root of 2 itself. Because root 2 times root 2 is just 2. Problem solved. And look, here's a fantastic little memory trick so you never ever forget this. Just remember the SS rule. If you have a single surd on the bottom, you multiply by the same surd. Single surd, same surd. See? Easy. Okay, let's see this SS rule in action. We've got 3 over the square root of 5. The rule says single surd, so we multiply by the same surd. That's root 5. Now, the really clever part is that we multiply by root 5 times over root 5. Anything divided by itself is just 1, right? So we're not changing the fraction's value at all, just how it looks. On top, we get 3 root 5, and on the bottom, a clean rational 5. And just like that, we're done. All right, you've totally mastered single surds. Level 1 complete. But what happens when the denominators get a little more complicated? For those, we're going to need a new tool, a secret weapon. So here's the difference. On the left, you've got a simple surd, like root 7. Our SS rule handles that, no problem. But look at the right. We've got a binomial surd. That means 2 terms, like 2 plus root 3. If we just multiply by root 3 here, it's not going to work. We'd still have a surd hanging around. Our old tool just isn't powerful enough for this. So here it is, our secret weapon. It's called the conjugate, and it sounds fancy, but it is so simple to find. For any binomial like a plus root b, the conjugate is just a minus root b. You literally just flip the sign in the middle. That's it. If it's a plus, you make it a minus. If it's a minus, you make it a plus. Now, the reason this weapon is so powerful comes down to this little bit of algebraic magic you've probably seen before, the difference of squares. Remember this? When you multiply a plus b times a minus b, you get a squared minus b squared. Notice how this squares both parts? And what happens when you square a square root? Poof, it vanishes. This is the key. Okay, time to put our secret weapon to the test. Here's our level 2 boss. 1 divided by the quantity, 3 plus the square root of 2. Our old SS rule is useless here, so it's time to call in the conjugate. First things first, what's the conjugate? Well, the denominator is 3 plus root 2, so we just flip the sign. The conjugate is 3 minus root 2. Now, exactly like before, we multiply the top and the bottom of our fraction by that conjugate. Again, we're just multiplying by a very clever version of the number 1. And now, you just get to watch the magic happen. Look at the denominator. We've got 3 plus root 2 times 3 minus root 2. Using our magic spell, that becomes 3 squared minus root 2 squared. Well, 3 squared is 9, and root 2 squared is 2. 9 minus 2 is 7. And just like that, the surd's gone. And there you have it. The final, cleaned up, beautiful answer is 3 minus root 2 all over 7. The denominator is a rational number, the fraction looks tidy, and we've officially beaten the level 2 boss. It's actually a pretty satisfying process once you know the secret, right? Okay, so we've learned the moves. Let's put everything together now into one single, foolproof game plan you can use every single time. Here is your game plan. 5 simple steps. First, just look at the denominator and identify its type. Is it a single surd or a binomial? That tells you which tool to grab, the same surd or the conjugate. From there, you just multiply the top and bottom, use that difference of squares rule if you need to, and simplify what's left. Following this process breaks any problem down into manageable chunks. Now, even the best of us can fall into a few common traps. So let's quickly go over what to avoid. The biggest one by far is multiplying only the denominator. Remember, you have to multiply by a form of 1 to keep the value the same. For the binomials, don't forget it's the conjugate you need. And of course, the classics. Watch out for simple calculation mistakes and always make sure you actually finish the job. No roots left in the denominator. Okay, so we've totally mastered the how, but let's take a step back and talk about the why. I mean, why do mathematicians even bother with this? Is it just to be difficult? No, not at all. Here's the core reason. Rationalization creates a standard simplified form. Think of it like this. We all agree to write addresses in a certain way: street, city, state, zip code. It's a standard that just makes everything easier for everyone to read and manage. That's all this is. And this standardization has some huge benefits. When all your expressions are in the same tidy form, it becomes way easier to compare them, to add them, or to subtract them. It's a foundational skill that honestly just makes more advanced math, like algebra and calculus, a whole lot cleaner and easier to work with. So, when you really think about it, what we've been doing today is taking something that looks messy and complicated and applying a clear, simple set of rules to make it orderly. That's one of the most powerful ideas in all of mathematics. Which kind of leaves me with a final thought for you. Where else in your life is the ability to simplify something complex a genuine superpower? Thanks for joining me.